All right, and this is section 13.2. We're going to be factoring trinomials here. Typically, when we factor, remember, factor just means you write as a product, so something times something else. First step we do is we look for a GCF. Second step is we factor by grouping. And then the third step is we do trinomials. Grouping is what we just did. Grouping is when you cut it down the middle and you take out a GCF from each half. Trinomials are what we're going to learn right now. When we're factoring trinomials, trinomial, we typically look at like ax squared plus bx plus c. The trinomial is 3 terms. And what we usually do is we multiply a and c together. And then from there, we look for 2 numbers that multiply to be AC, and they also have to add to be the middle value or the same. Let me show you what I mean by taking a look at some examples. The directions will just be to factor. And let's say we had x squared minus 3x minus 10. What we're going to do is I typically make an x like this, and I multiply the AC, meaning 1 times -10 is -10, and I put the middle value on top. So what we have to do is find 2 numbers that multiply to be -10. But the same 2 numbers have to add up to be -3. So this is where it's a little tricky. Can anyone think of 2 numbers that multiply to be -10 and add up to be -3? Yeah, so -5 times 2 absolutely gives us -10, and -5 times plus 2 gives us -3, right? Very good. One way that I find this is I just would factor 10, like using the prime factorization tree we talked about. The numbers that multiply to be -10 would be like, obviously 1 and 10, they're not going to add to be 3. But 2 and 5, as long as I make the 5 negative, then it all works. So it looks like -5 and 2, and it doesn't matter what order we write them in. So the hardest part is coming up with these 2 numbers. The way we go from there is we write the original problem, but instead of -3x, we write the 2 magic numbers here. So -5x plus 2x. What we're doing is we're forcing it to be an even number of terms, 4 terms, so we can factor by grouping. That's the whole idea. Cut it down the middle here, we could take out an x. We're left with x minus 5, take out a 2. we're left with x minus 5. And x minus 5 times x plus 2 would be the answer. Instead of doing -5 and 2, if you did 2 and -5, the answer would just be like switch, which is totally fine. Try another one here. How about x squared minus 5x plus 4? So first thing we always do is multiply the first and the last numbers together. And we're looking for two numbers that multiply to be 4, but they have to add up to be -5. Once we can figure those out, we go ahead and factor those. Anybody else? Anyone have any idea? Numbers that multiply to be 4, but add up to be -5. So factors of 4 are 1 and 4, 2 and 2. How can we use those numbers to come up with -5? Yeah, -4 and -1. They multiply to be +4, but they add up to be -5. So we're going to go ahead and rewrite this. X squared minus x minus 4x plus 4. And then we could factor by grouping, meaning we could cut it down the middle, take out an x, take out a -4. Then we get x minus 1 times x minus 4 is our answer. Let's mix it up a little bit. How about 2x squared minus x minus 3? All right, can you guys take a minute and do the same thing? Obviously, the difference here is the front number is, it's not 1, but you're still doing 2 times -3, and everything else is exactly the same. So what numbers multiply to be -6 and add up to be -1? -3 and +2, right? Hardest part is just finding those numbers, but what I would do is start with -6 and do 1 and 6, 2 and 3, and be like, okay, I have to add them up to get -1. So if I make the 3 negative, then those are the numbers. So we get 2x squared minus 3x plus 2x minus 3. Cut it down the middle. Take out a GCF of x. And sometimes the GCF is 1. You can't take anything out of the numbers or the letters. Sometimes you could just use 1. And you see this factor is just like all the other ones. 2x minus 3, and then x plus 1. Let's keep doing this here. How about 3x squared plus 16x minus 35? So the only way I can really make this harder is if I pick bigger numbers. 35 times 3 is 105. And they have to add up to be 16. So it might take a little while for us to find this. But let's try to figure out numbers that multiply to be 105, and then we'll figure out how we can clean out of that. So we could definitely use 1 and 105. 2 doesn't go to 105. 3 does. 105 divided by 3 is 35. But we can't add those and get 16. So let's keep going. 4 is not going to work. 105 divided by 5 is 21. But we have to somehow come up with 16. So if we use positive 21 and negative 5, we get exactly what we do. Cut it down the middle. Take out an X from each of these. Take out 7 from each. You get the same thing inside parentheses, which means we did it correctly. Get that as our answer. I have maybe 3 more to wrap things up here. What if you had 6x to the 4th minus 42x to the 3rd plus 72x squared? Remember earlier, when I started this section, I told you when you factor, we have to follow these steps. The first step, we figure out the GCF. Then we factor by grouping. Then we use trinomials. We always go in this direction. So this is a trinomial, but we could even take out a GCF before we even get there. Does anyone see a number we could take out of 6, 42, and 72? They're a GCF of the whole thing. So we could take a 6 out of everything. And an x to the 2nd. So we get 6x squared. And we're left with x to the 2nd minus 7x plus 12. What we did is we took the GCF before we even got to trinomials. All right, so we have a GCF. This one's all set. This is the GCF, but this is our trinomial now. So sometimes when you factor, it's like the gift that keeps on giving. You factor once, but then you might have to factor again and again and again. So let's take this trinomial. 1 times 12 is 12. Has to add up to be -7, so we could use -3 and -4. We're going to factor x squared minus 7x plus 12. We're going to factor it to be x squared minus 3x minus 4x plus 12. Don't forget the 6x to the second was there in the beginning. Cut this down the middle. We could go ahead and factor out an x here. Then -4, remember if the first number is negative, we get a negative. And we get 6x to the second. And then x times x minus 3. And then -4 times x minus 3. That's exactly right. Yeah, 12 divided by -4 is -3, right? And then we could go ahead and take out the GCF of x minus 3. And we're left with just x minus 4. So we okay with the -3 and the -4. Once you add them together, you get -7, and if you multiply it by itself, right? So we're okay after this step. What happens here is cut down the middle. We use in isolation. If you take an x out of here, then what is that? Right? We can take a -4 here, but this is where the question is. What's -4 divided by -4? It's called divided by -4, which it should be, because if you have each of the same thing, then we doesn't get it correctly. And then the way you write your final answer is just like this. Is just like, it doesn't matter what order you write it in. You can put 6x squared, x minus 4. It's called the commutative property of multiplication. It doesn't matter what order you write it. How about this? X to the third minus 2x to the second y minus 3x y to the second. In math, one thing that's really important is that you understand the numbers change, but the steps stay the same. So we still have 3 terms here. If there is GCF, we can take out of all 3 of them. Have an x, right? I can take an x out of all 3. The parentheses and the brackets, there's no difference with them. Now, the x is fine the way it is. This is the GCF, but this is our trinomial. So the fact that there's x's and y's, it doesn't matter. I think that's a song, x's and y's. Oh, x's and o's, I think. Yeah. There it is. Yeah. All right. So let's go ahead and multiply these. 1 times -3 is -3. And -2. Numbers that give us what we want here would be -3 and 1. So when we go to set this up, don't forget the GCF. But then we have x squared minus 3xy plus 1xy minus 3y squared. Just remember the rules. You take your 2 numbers, and that always breaks up what's in the middle. The middle is -2xy, so you're gonna have -3xy plus 1xy. The fact that there's multiple variables doesn't change anything. You can cut it down the middle and then factor by grouping. So we could go ahead and take out an X from these. Take out a Y from these. And luckily, we get the same thing here. Not luckily, that's the way it works. And we just get X minus 3Y times X plus Y. All right, we'll do one more and get out of here. How about 2x to the fifth minus 12x to the third plus 18x? All right, we'll do the same process we did before. As anyone sees GCF, we could take out of all three. 2x, right? So go ahead and take out a 2x from everything. And we're left with x to the fourth minus 6x squared plus 9. Again, don't get concerned because, we have x to the fourth, x to the second. It doesn't matter. The process is exactly the same. Now what we do is we do 1 times 9, but they have to add up to be -6. So I think -3 and -3 would get the job done. So we write our GCF. And then we have x to the fourth minus 3x squared minus 3x squared plus 9. So again, the middle term was an x squared, so we're breaking up the x squared into 2 separate x squared terms. Then we can cut it down the middle. We can take out a GCF of x squared here. And -3 because the leading term is negative. So remember, we have to take out GCF of negative if it's negative. And then we're left with x squared times x squared minus 3. Take out the -3. Of course, we have the same thing. Then tying it all together, we write 2x, the GCF on the inside, and then whatever's left over. So this would be our answer. If you want to get fancy, you could also write 2x times x squared minus 3 times itself. You don't have to do that, but just know whenever you square something, it means multiply by itself. Give you a second to finish that, and I want to show you one other thing before you leave tonight. Okay. Last thing I want to show you is, what if you didn't take out the right GCF from the beginning? What if you had like 2x squared minus 6x? Oh, no, wait. 2x squared minus 6x minus 18. Actually, no, sorry. I'm making this up on the fly here. 3 and 4. Make it like this. Sorry about that. We'll finish with this. So we know we could take out a 2 from the start, right? But what if you don't do that? You're not doomed for failure. What you can do is just do it like before. 2 times -8 is -16. Has to add up to be -6. We could use -8 and 2. We get 2x squared minus 8x plus 2x minus 8. Cutting it down the middle, we can take out a 2x. We could take out a 2. You wind up with x minus 4 times 2x plus 2. So again, I wouldn't recommend that you do this. I just want to show you that if you forget to take out a GCF in the beginning, it's not like the whole problem is ruined, right? What we get here, you just have to see your answer. Be like, okay, there's no GCF for this grouping, right? But here we can take out a 2. So the answer would be 2 times x minus 4 times x plus 1. It would be easier if you just took out the 2 in the beginning. But even still, you still get exactly the same answer. So next time I see you on Wednesday, we're going to be practicing this, a lot more.